go through the slide. So this is the sedimentation concept. So I've already introduced you. V naught is equal to Q divided by ES, H divided by T. So just look through your notes in your book, okay? If there is any things to write down. So I think there's nothing. Write down from page. Where's the page? Page 53. Okay. So I think that you have already put this equation. Okay. V naught is equal to Q divided by ES and is equal to H divided by T. So that is that. Okay. So complete. I think nothing to write down there. Also nothing. Okay. This is the formula of calculating the percentage removal. If you remember that you start with 100 milligram per liter of silicon, and then at certain point, at certain time, the concentration is 60, and then you have to find out the percentage removal, right? So this is the formula. I think you know that. You don't really have to memorize this. And then, yeah, this is another thing that I would like to emphasize, okay? Scale up factor of 0.65 for overflow rate and 1.75 for detention time to be used to design the tank. So what it means, okay, remember, when you want to design your sedimentation tank just now, you were using a lab scale experiment using settling column, okay? So those are in the experiment using settling column. So for our example just now, it says when you have 0.15 meter per minute, if I'm not mistaken. Was it? Can someone remind me? The V naught. What's the V naught for our just now? 0.15 meter per minute, is it?
Yes, 0.15.
Right. So it says that if you have 0.15 meter per minute, the percentage removal is 77.5%. So that is from that experiment using settling column. So if you want to design the real tank, that value, which is 0.15 meter per minute, has got to times with the scale up factor of this value. That means 0.15 times 0.65. So just plug the number in the calculator, 0.65 times 0.15. You got the value to be 0.0975. So the real thing is, if you have a design of a tank, the tank has got to have a V naught to be 0.0975. Then only it will remove 77.5%. Okay, so not 0.15 meter per minute, but 0.0975. Or in other words, the detention time in our settling column, it says that when you have 10 minutes, you can remove 77.5% of particles. But you have to times with the detention time scale up factor for the real tank, okay, which is 10 times 1.75. So it's in reality, if you want to design a sedimentation tank, the detention time has got to be 17.5 minutes. Then only it will be able to remove 77.5% particles. Okay. So is that clear? The purpose of scale up factor, okay? So this is to match or to make the real design of a sedimentation tank. The one that you got results just now was through experiment. So that's not the real case. So you need to times with the scale up factor. That's what it wants to. That's the purpose of these scale up factors. Okay, guys? Can I proceed?
Yes.
All right. Okay, so example 1, data is given by the lecturer. So this person is more ambitious than you guys or than we, because they are doing experiment up 120 minutes, okay? And then checking at every depth, different depth, and then they find out the percentage removal. And look at the question. It says that given the C naught is 400 milligram per liter, the overflow rate is given. You see, the overflow rate is given. Now they want you to find out the effectiveness of the tank. Okay, just like that, what we did. So the overflow rate is given, and we need to find out the effectiveness of the settling column. See, they didn't say of the tank, of the sedimentation tank. If it says of the sedimentation tank, then perhaps you have to times with the scale up factor. But this one is just of the settling column. So this also settling column. The effectiveness of the settling column is to be found out. Right. You have data like this. So the next step is you have data. Then what you need to do? The first step. Anyone making a guess?
Plot.
Plot graph. Okay. So you need to plot graph like this. So we can always just check, just pick up whether it's correct or not. So at time 40 minutes, height 1.2, so the percentage removal is 58. Is it true? 40 minutes, 1.2. So yes, 58 minutes. 58%. 58%. That's correct. So I hope that this lecturer has already labeled the points correctly. So the next step is to draw the ISO concentration lines. Okay, like that. They draw the ISO concentration lines. You see, the first ISO concentration line that they draw is 100%, then 70% line, and then 60% line, and surprise, surprise, the last line is 54% lines. So they don't pick a nice number like 50, 60, 70 only, but sometimes 54% also can be used.
Doctor,
Yes.
why did we take line at 40 minutes?
Right. Okay, we were given the overflow rate now. Okay. So from overflow rate, you can find out your detention time. So divide, by using formula H divided by T. So now you tell myself, okay, you tell me, what is your T? Try to get your T. I want it to be in minutes, not in hour. Can everyone try to attempt? Okay, overflow rate is given. Then find out your T. Overflow rate is equal to H divided by T. So write down your attempts of answer on page 55, part 1. Our H is 1.8. So 1.8 divided by 2.7 should be something in hour. Okay. So from that hour, you need to change it to minutes. So what minutes? What is the time in the minutes? Have you already got that?
40.
40, thank you. Okay, 40 minutes. So you see? So you get 40 minutes for the guy who asked me just now. I don't know your name. I can't see your name actually. You got it already?
Doktor.
Yes.
H tu kan, kita memang kena ambil yang paling bawah.
This is the height of the column.
Ke kita kena pilih satu tak ya?
No. This is the height of the column. What it
Oh, height,
means, you want to design the tank that height is 1.8. That's why they have the settling column to be 1.8.
Okay.
Right. Okay. So if they want to have a height of settling tank or sedimentation tank to be 2 meters, then they have column of 2 meters. Okay. So that's why this person got that 40. Or they choose 40 because of the overflow rate is given and they calculated the T to be 40 and they straight away go to this 40 and trying to measure off the delta H, and delta H like that.
Doctor, sorry.
Sorry. Got it already, right?
Okay, noted with thanks.
Okay, no problem. Right, now our next step is, that's why this is given there, 40 minutes. And then plot the graph, you've done that. No need, it's being printed already. So we need to find out our RT. Okay, this is something you need to fill on page 55, part 3. So our RT, H1, delta H1 is 0.46 divided by the height of the column 1.8, and that is 100%, and this is 70%. So you got that 100 plus 70 divided by 2. And the next one is this distance, delta H2, 0.55 divided by 1.8, and this line is 70, and the third line is 60. So that 70 plus 60, 0.55 correspond to this distance, okay, divided by 1.8 height of the column. And then the last part, this height, 0.79, okay, divided by 1.8 times 60%, and it happens that that point at 40 is 54%. So 60 plus 54 divided by 2. 60 plus 54 divided by 2. And eventually you will obtain your answers to be 66.6%. Okay? All right. So can I stop now?
Yes. Yes, Doctor.
Okay, no problems.